Hello everyone, I hope you are doing well. Welcome all in this new video. In this video, we will know about Pandas, that is a Python library. We will also work on some example using Pandas and its functions. So before going deep dive into video, my name is Udaivan and my YouTube channel name is Analyst Today. If you are someone who love data science and machine learning, then this is right place for you. You can subscribe to my YouTube channel for my future videos. So let's get started. So I have opened my PC and I will open my Jupyter notebook. For that, I will first open command prompt. I will type Jupyter notebook and that will open Jupyter notebook in my browser. So yeah, so notebook is open here. I will go to Jupyter work. I will open this notebook all about pandas. So you can see, wait a second. Yeah. So as you can see, I have already written and done the part of data pre-processing and data loading, everything which you need to know about pandas. So I will explain cell by cell. So first, as you can see, I have given the introduction. So pandas is a powerful and flexible open source data analysis and manipulation tool built on top of Python programming language. So it is built on Python programming language. It provides easy to use data structure and data analysis tools for handling and manipulating numerical tables and time series data. So, and also you can load, manipulate data sets, perform aggregation and transformation, create visualization, and perform advanced statistical analysis all within Python. It is all essential. It is an essential library for data scientists and analysts working with large data sets. So this is about Pandas introduction. Some of the key features of Pandas. It is fast and efficient data frame object for data manipulation with integrated indexing. It is a good tool for reading and writing data between in-memory data structure and different file formats. So you can, read and write from the different file formats also. So it is useful in data alignment and handling of missing data. It is used in reshaping and pivoting of data sets. And you can see it is used in label-based slicing, indexing, subsetting of large data sets. And in pandas, columns can be inserted and deleted from the data structure for size mutability. And the group by function of pandas allows us split, apply, combine operation on data sets. So these are the key features of pandas. So let's move on to the data preprocessing. So data preprocessing an important step in data analysis process. So as it ensures that data is clean, correct, and ready for analysis, here are the general steps involved in data preprocessing using pandas. First one is load the data. Second is explore the data. Third is clean the data. Fourth is transform the data. Fifth is split the data. And the last is feature scaling. So we will see the examples of all these steps. So don't worry. So I have done the rest of part in the notebook. You will see here. So for the examples, I have taken a data set that is California housing price data set. So first we will load the data. For loading the data, before loading the data, we will import the necessary libraries for the loading data. So this is these two are the necessary libraries. Like whenever you are doing some data analysis part, you should import these libraries. So I have imported numpy and pandas as np and pd respectively. So first is load the data. The first step is load the data into a pandas data frame. This can be done using read csv function, which reads a csv file into a data frame. So I will read the data set, that is housing.csv, as a housing. So I have read the data here in this cell. So I will run this cell. So before running this cell, I need to run the first one. So I will run first cell. First one is successfully run. Then I will run this housing is equal to this pd.read csv. So it will read my CSV data set as housing. So it will name it as housing. Then I will change it into a data frame. So I will do the pd.data frame over the data set, that is housing. So I will run this cell to change my data into data frame. By using df.shape, so it will show me the shape of the data frame. So the shape of data frame is 2640 comma 10. So 20k 640 into 10. So this is the data set shape. And the next step is explore the data. Once the data is loaded, it is important to explore it and get a sense of its structure and content. So you can use the head and tail function to view the first and last few rows of the data, and the describe function to compute basic statistics about the data. You can also use the info and data types function to get more information about the data types of the column. So we will do all these things. We will use all these functions. So first, I will try to know about the columns in the housing data. So as you can see, I have these many columns in the housing data. So remember it. The next cell is df dot head. This cell will show me the top 5 rows of my df data frame. So I will run this cell and this will show me the top 5 rows. So as you can see, there are so many columns which are already which we have seen already in the the fifth column, fifth cell, that is this cell. So as you can see, longitude, latitude, housing median, age, total rooms, all these columns are there. So we have not missed anyone. So ocean proximity is the last one, then ocean proximity is the last one here. The next cell is df.describes. So this function tells about the staticals, basic statistics about the data. So we will do this, and you can see we are able to see the total count of all the columns and the mean of that values in that columns, the standard mean, and then minimum values of of those column, top 25%, top 50%, top 75%, then the maximum value of that particular column. So this is the statistical basics about the data frame, that is df. And the next is df.info. It tells about the data types and the total non-null counts. So the column longitude, latitude. So this column tells us the column name, and this column tells a non-null counts. So there are total 20 20k 6640 uh, count about in this data set. So as you can see, most of the columns are having non-null values except this total bedrooms. So the third column tells about the data type of that particular column. So longitude is float 64 data type. The ocean proximity is only data type, only column that has the data type as object. So there are total nine columns which are having float 64 and one column that is having object data type. So df.data types, you can see the same thing which we have seen already here. The next step is clean the data. So the next step in this next step, like to clean the data by handling missing values and ensuring that the data is in a consistent format. So in data cleaning part, we see that what are the missing values, and then we do some I mean placeholder to fill those missing values. So we will see that df dot is na dot sum. This functions, this is the this function tell us if there is any null value in the data frame or not. And after that, if we use that dot sum, then it will count the total null values in the data frame. So we will we will run this cell and we will see how many null values are there in the data frame. So as you can see, no null values in longitude, latitude, except in fact there is no null values in all the data frame except total bedroom column. So total bedroom columns has total 207 null values. So we will fill that values, those null values, with the median of the total bedroom columns values. So we will take the median of total bedroom column and we will fill that those null values with the median of this total bedroom column. So this way you can fill the null values. There are so many. There are some other methods also. By using those, you can fill the null values. But for the simplicity, I will use the dot median only. So we will get the median of total bedroom column, and you can see the median is 435. And using in this cell, the next cell, df total bedroom is equal to df total bedroom dot fill na, then this value median med. So it will do it will fill all the null values, na values, to the value of median. So let's run this cell and let's see what happens. So again, to verify, to check whether these null values have gone or not, we will do again df dot is na dot sum. You can see no null values in the total bedrooms. So we have cleaned the data. In fact, as you can see, there are no null values. The next step is transform the data. So the next step is transform the data. After the data is cleaned, you may need to transform it by adding or remove columns or by changing the data types of the column. You can use the assign function to add new columns, draw function to remove columns, and the s type function to change the data types of the column. So in the data set which I have taken, actually there is no option, there is no need to, I mean, remove or add the column, remove the column, but there is basically there is a object data type column, that is this column, as you had I had shown, like OSIN proximity. So if we do the one hot encoding in this column, that is a categorical feature because this has some category values. So we will do one thing, we will replace that category values with some number. So this is what one hot encoding is. It is a technique used to represent categorical variables as numerical data. It creates a new binary column for each unique category in a categorical variable, and each row has a 1 in the column for the category it's belong to and a 0 in all other columns. So this is about one hot encoding, and we will do this one hot encoding using get dummies function of pandas. And we will do this get dummies function. We will use this get dummy function on this df ocean proximity, basically you can see series. So I will run this cell and I will get the dummies for these this ocean proximity column. So sorry. So I have run this cell. I have got the result. I will show the top five dummies for this ocean proximity column by running this cell. So the cell number 15, it shows the dummies for this ocean proximity column of our data frame. So as you can see in the top five column, uh, here in the df dot head, top five columns are having nearby ocean proximity, and in the dummies also top five are having nearby ocean proximity as near base value are 1. So this way you can verify whether your dummies are correct or not. So what we will do, we will concat these two data frame, that is ocean prox and the one is df itself. So we will concat df and ocean prox, and we will write this pd dot concat, then df comma ocean prox and x is equal to 1. So we will run this cell, and what we will do, what this function will do, it will concat these two columns, these two data frames. So and then we will drop this original ocean proximity column by using df dot drop function, and let's run this cell, and you can see that cell is successfully run. And to check whether we have done all these things correct or not, we will check df dot head. We will do df dot head, and you can see there is no column named as ocean proximity now because we have dropped it. And instead of ocean proximity, we have added five different columns, that is uh, 1H ocean, inland, is land, near bay, near ocean. So these are the categorical features. These are the categorical variables that we are in ocean proximity column. So now these variables are having their own columns. So as you can see, we have done everything correct till now. We will check the shape of the new data frame. So the data frame shape is 20k 640 comma 14. So it's correct. The next step is split the data. If you are planning to build a machine learning model, you will need to split the data into a training set and a test set. You can use the train test split function from the sklearn.model selection module to split the data into these two sets. So first I will import the libraries which are necessary. So from sklearn.model selection, import train test split. So I will import this train test split by running this cell, and it will import this necessary library. Okay, so what we have to do, what uh, so we have to define x and y. So for the y is the value of that house, that house. So in the data frame, as you can see, this column is the uh, value of that price, and all rest columns are the input variable. So this is the output variable which we need to predict, and rest of columns are the input variable. So I did not told about the data set, but I will brief about data set. So the data set here is to predict a housing price of the to predict the price of the house in California. So there are some input variables, and this is the output variable. So house price is the output variable, and rest are input variable. So we will do this here. We will take house value as y, that is our output, and by dropping the house value column, rest are our input. So we will drop the house value column, and put on in the x variable, that is our input variable. So y is our output variable and x is our input variable. So we will run this cell, and go to the next cell, and this cell will split our split the data into training and test set. So we will write train test split, and we will give the x as input and y as output variable, and our test size is zero point 0.2, and basically 20% of the data will go into test size, and 80% of the data will go into train set. So this is our test size, and the random state is 42. You can change it, so no issue. So we'll run this cell, and I will get the x train x test and y train y test. So we have done this till the split the data part, and then the next part is feature scaling. So feature scaling, many machine learning algorithm requires that input features are scaled to a uniform range. You can use the standard scaler class from the sklearn.preprocessing module to scale the feature to a standard normal distribution. So this is the basically library sklearn.preprocessing. We will import the standard scaler from that module. So we will run this cell, and it will import the standard scaler. So I will run this cell. Okay, so then again I will define the standard scaler as a scalar, and I have defined here. Then again I will do the fit transfer on x10 and x test for the feature scaling part on our external and x test data set, x test data. So I will run this cell, and I will uh, do the feature scaling thing on these two data set. Okay, so uh, this is done till the sixth and the last part, that is feature scaling. So once again I will go through the all the steps which I showed you here. First, introduction, you can see, and then the most important thing we do using pandas, that is data pre-processing. This involves load the data, explore the data, clean the data, transform the data, split the data, feature scaling. So we will import the pandas as pd, import pandas as pd. By running this cell, we will import pandas. Then we will load the data, and the data set is California house price detection. So this is the data set. I will give the link of this data set in the description. Don't worry. So We will read the data using pd.readcsv function, and we will make the data frame using pd.dataframe. We will check the shape of the data frame using df.shape. Then again, we will check the columns of the data frame using the housing.columns. Then again, we will show the top 5 rows of data frame using df.head. We will describe the statistical values of the data frame using df.describe. Then we will know about data frame using df.info. We will know about data types of the data frame using df.datatype dtypes, and then again for cleaning the data, we will check if there is any null values. So we will do df.isNA, and it will show me the null values. But if we want to sum all those null values, we will do the dot sum. So df.isNA.sum will give us the uh, null values, total null values in the df data frame. Then again, we will take the median of the data frame. So using df total bedrooms dot median. So this will give us the median of the data frame. Data frame column, that is, the name is total bedroom. So the column's name is total bedroom. So the median of that column is 435. We will fill that. We will fill those null values to the median of that total bedroom column using this fill na function of the data of the pandas. And again, we will check if there is a null values or not. So there is no null values. And again, a brief about the data. The data set uh, helps us to predict the how pricing house price of the uh, California city. So there are some input values, and using those input values, we will predict the price of that house in the California city. So, and the one column is in the data frame is OSIN proximity that needs to be changed into uh, uh, numerical variables because it's a categorical variable. And in the machine learning, we do not in the machine do not basically uh, uh, knows the categorical variable as basically machine learns only numerical values. So we will change it into numerical values. So OC proximity column is changed into numerical variables. So the variables are ocean, inland, island, nearby, near ocean. So basically, there are total 5 new variables that will be added to our data frame. So we will uh, concat uh, this new data frame to our original data frame, that is def, and then we will drop the original ocean proximity column, that is ocean proximity, and we will check that df dotted whether it is whether our new data frame is correct or not. So everything is correct here. So we will again check the df dot shape. We will again check the shape of the new data frame using df dot shape. And next part is split the data. Then we will import rain test split from sklearn.model selection library, and we will define the x and y, basically input and output variables of our data frame. So we will do the train test split on x and y, and we have taken test size as zero point 0.2, and random state is equal to 20. So this will give us the x train, x state, y train, y test. So this is done here. And the next and the last thing is feature scaling. So we will import the standard scaler, and we will define it in standard scaler as a scalar, and we will do the fit transform method on the extrain and extest data sets. This will this will transform our extrain and extest. Okay, so summary is Panda is a Pandas is a powerful data manipulation library in Python that is allows you to clean, transform, and analyze data efficiently. And data preprocessing involves loading, exploring, cleaning, transforming, splitting, and scaling the data to prepare it for analysis. Yeah, thank you. Thank you for watching this video till the end. Please subscribe to my YouTube channel and give a thumbs up to this video. Bye bye.